Good morning, students. I have a very important message to tell you, or teachers, or whomever is watching this. This is very important. We're halfway! Oh, and I misspelled, I don't know where that P came from, but we're halfway! 5.1, there's 10 units. 10 units divided by 2 equals 5. We're halfway. So after today, everything's downhill. It gets easier. Yeah, just kidding, it doesn't, but we're halfway. That's awesome. Oh, it's such an exciting day. By the way, all of these videos, including the half before this and the half after this, can be found at www.nkinfinity.com. Today we're going to discuss simplifying rational expressions. Oh my gosh, rational expressions. Oh, I tell you. Does the world get any better than simplifying rational expressions? I don't think so. No. I think you're going to say, wow, you could go on the date with the most exciting person ever or rationalize expressions, and you're like, dude, I'm going to simplify some rational expressions. It's a lot more fun. All right, we'll go. It's not that exciting. I'm excited. Whatever. All right, simplify. I can't get this any bigger. I have to change that. I didn't like this color. Gone. Simplifying. Now, when they're just fractions like this, they're pretty easy, right? This x cancels with one of these x. This 2 goes into 4 twice. Notice there's nothing left on the numerator. That doesn't mean there's nothing there. No. There's still a 1 there, and the denominator is 2x. So don't be silly. By the way, you should never, ever get one of these wrong. Oh, I'll get my calculator up and I'll explain why in a minute. All right, let me get that. There it is. Wait, there it is. There she is. All right, so the original problem was 2x over 4x squared. Now, it doesn't matter how complicated or uncomplicated it is. All of this can be done on the calculator. So go into calculator mode. You go, let's see. I'm going to just take 2.157. It makes no difference. You can pick 2.1, by the way. And I'm going to just store it in x. Makes no difference what you pick. Every time I don't get the x, it makes me so angry. So the original problem was 2x over 4x squared. So control division 2x over 4x squared. Now I know this is a really simple example to show you how to check it, but you should be able to check all of these. Yeah, it takes a couple seconds. Ooh, sorry to waste your time. My recording, because I want to make sure I'm getting my good sarcasm in there. And then our next answer was control division 1 over 2x. Pacham, they match, you're done, you got it right. Okay, so no reason to get any of these wrong. You get them wrong, it's embarrassing. All right, just like when we talked about factoring the last unit, the first rule of factoring is always take out the GCF. So in this case, x is my GCF. So if you take an x away from this and you take an x away from this, remember, there's still a plus sign here. So you have to fill 2 holes, one before the plus sign, one after the plus sign. So if I take an x away from this first one, I'm left with 3x. If I take an x away from x, I'm left with 1. When all else fails, I mean, think about it. If I redistribute, I get 3x squared plus x. All right. So now this x cancels with this x. So I'm left with 3x plus 1 all over 5-bagger. Bam. Factor. Dots. We have dots. Difference of 2 squares. So x plus 4, x minus 4, all over x minus 4. Now don't be that kid that goes, oh, you know what? What I think I'm going to do is this. I'm going to do this. X goes into this x right here. That done their work. And then I'm going to take that there 4 and put it into that there 4, and I get x minus 4. And you'll be like, man, I was so close to the right answer, because the right answer is, well, look, the x minus 4 is canceled. The right answer is x plus 4. Yeah, you were only 8 off. You cannot do this. Don't do it. It's stupid. It's juvenile. Put parentheses around binomials so you don't do anything stupid. And then factor away. Right. GCF, what can I take out of the numerator? I can take out remember, we're going to put parentheses around this so we don't do anything stupid, right? I can take out a 25. I'm left with x minus 5. In the denominator, what can I do? DOTS. D-O-T-S. It's dots. Dots. Gosh. The power of Dunkin' Donuts coffee. when I wake up in the morning and don't feel like shooting videos in the middle of summer for my students in the fall who may or may not appreciate it, I drink Dunkin' Donuts coffee. Will you? Oh, nailed it! Oh, gosh. I'm telling you, Dunkin' Donuts is going to be beating down my door soon. They're going to be like, Mr. Krause, we want to pay you millions of dollars for your commercials because you are a natural. So I just factor the denominator, dots, do difference of two squares. The x minus 5s go. None of this should be anything difficult. Now watch what I'm going to do here. If I leave this x plus 5 like this, I'm like, oh, I'm so tempted. I'm so tempted to cross that 5 out, divide that 5 into that 25. I'm so tempted. But then I go, oh yeah, Mr. Krause said put parentheses around. Oh, I almost did something stupid. Oh, man. Thank God. Thank you, Mr. Krause. Thank you for teaching me to put parentheses around binomials so I don't do anything stupid. Makes me feel so good about myself. All right, let's factor. Ooh, we got dots again. D. O. All right, that's old. So the numerator, I got dots. X squared minus 1. So I go x, 1, 1's plus, 1's minus. That was some tough stuff there, kids. Let's factor that denominator. Oh my gosh, what multiplies to 2 and adds up to 3? X. They both got to be positive because that's positive and that's positive. So they both have to be positive. Guess 1 and 1's 2, right? Because 2 times 1 is 2 and 2 plus 1 is 3. So I come over here with my purple pen. I say, kabam, kabam. I think crossing stuff out is quite fun, actually. All over x plus 2. Almost done, chillin'. I have to put me some parentheses around these things, so don't do anything dumb. The denominator is easy. It's just x minus 6. In the numerator, we got to take out a GCF. In this case, we're going to take out a 2x. Ooh, that's a fancy 2 with a big old head. When I take a 2x away from this, I'm left with x, minus 6. Isn't that weird how that always seems to work out? Gone. My answer is just 2x. Silent commercial. Oh, it doesn't get any better. All right. My commercials suck. Sorry. No way I'm getting Dunkin' Donuts sponsors now without you guys helping me. You know, you guys could contact Dunkin' Donuts and say, you know, Mr. Dunkin' Donuts, I have a sponsor. I think you need to sponsor Mr. Krause, Miss Newman. They're amazing. Amazing. And you're like, who's Miss Newman? Watch the geometry videos. You'll know who Miss Newman is. She does the geometry videos. And she is the brains behind this entire operation. I'm not even gonna lie. She's the brains behind this entire. I'm just a good looking spokesperson. All right, whatever. I'm almost 50. Give me a break. All right, so the numerator is a fourth degree, or is a cubic. We got we have 4 terms. It's a polynomial. You know we're gonna be busting that baby up. So in the first one, I can take out an x squared, and I'm left with x plus 3. Oh, look at that. Don't you dare cancel that right now. I will knock the living snot out of you. In the next one, this group here, I really can't take anything out, so I take out a 1. Don't forget. Do you notice that theme came up a couple of times? Don't take anything out, take out a 1. Take everything out, leave a 1. All right? Think about it, okay? Think about it. X plus 3. Now, I'm not done yet, because if I was just to cancel one of these things, I'm just going to give you a big piece of advice. If you have adding and subtracting, you are not allowed to cancel. You're not allowed to divide out, and you can't divide if you have adding and subtracting, okay? Unless it's in parentheses, and then it's one big term, okay? One big binomial. So in the numerator, what I'm left with is x plus 3 times x squared plus 1, just like we did in the last unit, all over x plus 3. All right, now I'm allowed to divide out those common factors, and I'm left with x squared plus 1. All right, let's move on. Let's make this more interesting. Whoa, crazy. Rationalizing denominators. You thought it couldn't get any better, and here we go. We're going to be rationalizing some denominators. Let me ask you a question. Oh, new rule. I forgot we have a new rule. What movie is that from? New rule. New rule. No radicals in the denominator. Denominator. No radicals in the denominator. no i's. That's the imaginary number. That is the square root of -1, the imaginary number. In the denominator. We got to get rid of it. So let's recall a fact that I know. I know that the square root of 3 times the square root of 3 is equal to the square root of 9, which is equal to 3. I know that the square root of 2x times the square root of 2x is equal to the square root of 4x squared, which is equal to 2x. So in general, I know that the square root of any number, anything, I don't care if you put a big flaming pile of dung underneath there. If you take the square root of a big flaming pile of dung and you multiply it by a big flaming pile of dung, what you get is dung. Dung is poop, by the way. You don't want to do that. But any radical of some number times any radical of that exact same thing equals that number. Because what you're doing is you're taking it and you're really squaring it. But we're going to be multiplying by this. And then I have a really, and then don't forget, can't get rid of it. And don't forget I times I is really I squared. And don't forget that's equal to -1. So here's two simple facts start up for you that you're going to have to remember. What was I going to tell you? I was just going to tell you something. I got to pause and think for a second. Coffee's not working. I have no idea what I was going to say. Anyway, let's just get going. Let's rationalize the denominators. Oh, I know what I was going to say. I was just about to say that. Okay, so I've got some very important information to tell you. This is very, very important. What is 5 divided by 5? Is that equal to 1? What is 2.7 divided by 2.7? Is that equal to 1? What is 3x squared over 3x squared? Oh, is that equal to 1? What is y over y? Is that equal to 1? What is I over I? Is that equal to 1? What is the square root of 8 over the square root of 8? Is that equal to 1? Do you get it? What is the square root of 2xy squared over the square root of 2x? Nothing. I tricked you. It's really just y, but y squared. Oh, is that just 1? Oh, yeah, it's just 1. So I can represent 1 any way I want. And by the way, that's a trick for the SAT. Oftentimes, they'll have rational expressions or irrational expressions a lot of times on an SAT. And if you realize that you can multiply by 1 and represent it any way you want, oftentimes you'll be able to get a problem done. There's a couple of problems that they always ask on SATs that are very, very similar. And you're like, whoa, that problem can't be that easy. You know, for those of you who have taken SAT questions, you're like, what? That question was that easy? Ah! For those of you that haven't, practice, because they got some tricky questions. So what we're going to do is use that idea. Because by the way, what is 8 times 1? 8. What is 27 times 1? 27. What is anything times 1? Doesn't change its value. So that's what we're going to be doing right now. We're going to be multiplying by 1. So I'm going to, I need to get this. Can I get this bigger? Oh, I can get this bigger. Yay. So what we're going to do is we can't have this radical in here. And so what we're going to do is we're going to multiply by 1. 1. So then I get 5 over radical 3. Oh, crap, that didn't help out. So we're going to multiply by 1 again, times 1. We get 5 over radical 3. Oh, crap, that didn't help out. Okay, so the definition of insanity is doing the same thing over and over again, doing the same thing over and over again and expecting different results. That's not going to help us. But I just said I can represent 1 any way I want because I'm the teacher. So that's what, and you're the student, so you can do it too. I'm giving you permission. So what we're going to do is we're going to multiply by 1, but we're going to represent it as the square root of 3 over the square root of 3. I'm going to represent it by the thing I want to get rid of. But square root of 3 over the square root of 3 is still really just multiplying by 1. So whatever I end up with should be over 5 over radical 3, but it might look a little differently. So let's multiply this across. Let's see what we get. 5 times radical 3 is 5 radical 3. I'm only going to do this once, by the way. Radical 3 times radical 3 is radical 9. And you might be thinking, oh, you still have a radical in the denominator. You're a terrible teacher. I will come through that camera and just slap you silly. No, I wouldn't do that. 5 square root of 3 over, and then square root of 9 is 3. So I would expect that you go from multiplying these together to just getting 3, because it's true every single time. That was example 1. Let's do example 2. All right, this time I want to get rid of radical x. So I'm simply going to multiply by radical x over radical x. And I get 2 radical x over, what is radical x times radical x? X. Bodied. That means done, kids. All right, this case, I don't like i's. It's in the denominator. I got to get rid of it. Now, I need to tell you that's not a variable. I need to tell you that's the imaginary number I. The I that's equal to the square root of negative 1. So anyway, I'm going to multiply by I over I. I like multiplying by I. Oh, God. You're wondering why I'm drinking so much coffee. It's my first cup of the day, and it's the most important. It's the most important meal of the day. In the numerator, I get 7i. In the denominator, I get I squared. But you need to remember that I squared is really negative 1. So 7i. So my final answer is negative 7i. There's my answer. Moving on. All right. I don't like the 3. No, I don't care about the 3. I don't like the I. So the only thing I don't need to get rid of the 3. I need to get rid of the I. I need to get rid of the I. So I'm going to multiply by I over I. So in the numerator, I get xi. In the I always have this kid who goes, oh, the i's cancel. No, don't do that. In the denominator, I get 3i squared. And they're like, oh, that I cancels with another I, and up with x over 3i. No, you goofball, don't do that. So what I end up with is in the numerator, I end up with xi. But remember, this is really negative 1. So in the denominator, I end up with negative 3. I don't like looking at negatives in the denominator. Throw it out front if you want. Throw it in the numerator. I don't care. There's my answer. This is going to be awesome. Here's what you're going to do. You know how every day you come home from school and you're like, oh, Mary. Oh, John. Oh, Jill. What did you do in school today? You know, you're at the dinner table. Your mom's like, hey, what'd you do in school today? Oh, Mom, let me tell you, I was rationalizing binomial denominators with these radicals and these additive inverse with conjugates. It was so exciting. Just do that. Go home and just say, Mom, you know what? In math class, we were rationalizing binomial denominators. They had these silly things, radicals and denominators. We had to take care of the conjugates, and then we had to multiply. Oh, my God, it was so exciting. You should have been there, Mom. You should have been there. And then have them explain to you how to do it. Just, you remember that, Mom? You remember that, Dad? Yeah, well, you did that in school. Here's the problem. Why don't you do it for me? Oh, good. Now leave me alone. I just want to eat dinner and be peaceful. Gosh. Talk to your parents, kids. My kids are gone now. They're out of the house. It's because I'm old. Actually, my son goes back to college on Friday. It's a little sad. I'm not going to lie. So here we got. We're gonna have now binomials in the denominators. It makes it makes it quite a bit more difficult when binomials. So the way we're gonna get rid of these is we have to multiply by the conjugate. Actually, what we're multiplying by is 1. We're going to represent, because remember, we can multiply anything by 1, but we're going to represent it as a conjugate. So let me give an example of a conjugate. If I gave you 3 plus the square root of 2 as a binomial, its conjugate would be 3 plus the square root of 2. Oh, brain cramp. It would be 3 minus the square root of 2. Notice the only difference is the sign in the middle. If I gave you something like a plus the square root of b, oh, its conjugate, well, let me just change it up and make it a little more exciting. What if I gave you a minus the square root of b? Well, its conjugate would be a plus the square root of b. What if I gave you 7 minus I? Well, its conjugate would be 7 plus I. So what new vocabulary word? The word conjugate. Same binomial with different sign in the middle. Some seriously awesome penmanship there. I know, it's exciting. All right, let's talk about this baby. First and foremost, I don't like the fact I got that negative where it is. Negatives should really always be in the numerator. So I'm just going to move it because I don't like it there. Don't like you there. So I'm going to put you up here in the numerator. All right, so here's my denominator. I still need to multiply by 1, but we know that based on the crap I did in the last little section, that would be stupid. So we're going to represent 1 any way I want, and we're going to use this idea of conjugates to do so. Now, some of you are like, why are we doing that? And then, you know what I tell you? Shut up! Just listen! Gosh. Oh, the screaming in my basement is killing me. Just kidding. So anyway, we're going to multiply by the conjugate. You'll see why in just a second. 5 minus the square root of 3. 5 minus the square root of 3. Now, I will forewarn you, do not distribute in the numerator. Don't distribute in the numerator. Did I say don't distribute in the numerator? What I meant was don't distribute in the numerator. Just leave it. So I'm just going to put this stuff next to each other. So it's negative 7 times 5 minus the square root of 3. You'll see why it won't be apparent on this problem, but in the future it will be. Now, in the denominator, we actually should double distribute. You'll find out that we don't need to double distribute, but we're going to do it on this one anyway. 5 times 5 is 25. 5 times negative square root of 3 is negative 5 square root of 3. Square root of 3 times 5 is plus 5 square root of 3. And the square root of 3 times the square root of 3, positive square root of 3 times a negative square root of 3 is minus the square root of 9. Now, I'm not going to do this problem this way ever again, so pay attention to what's going on. Notice these terms always cancel. They will always cancel because one's plus, one's minus, they're exactly the same thing. So the middle terms will always cancel. And we also know that this is really just 3. So my final answer here is negative 7, 5 minus radical 3, all over 25 minus 3, 22. All right, let's keep going. So I don't like this. So I'm going to multiply by the conjugate. The conjugate is radical x minus 3. Radical x minus 3. Don't distribute in the numerator. It won't be obvious on this problem why either. It will in a few minutes. Square root of x minus 3. All right, so we're going to do this one more time. It's the last time I'm going to show you. The square root of x times the square root of x, I am only going to tell you that's x. Square root of x times negative 3 is negative 3 square roots of x. The positive square root of 3 times square root of positive 3 times the square root of x is positive 3 square roots of x. Notice those two cancel. They will always cancel, so don't bother doing them anymore. And positive 3 times negative 3 is negative 9. So my answer is 4 square roots of x minus 3 all over x minus 9. Keep everything in parentheses so you're not tempted to divide out common factors. Silent commercial. Who would know that would be so powerful? All right. I is the problem. Not me, but this imaginary number I is the problem. So we're going to multiply by the conjugate, which is 8 minus I over 8 minus I. Make your eyes look like that. Don't go like this. They look like ones then. Don't do that. Make them look fancy. Put a little bubble eye. You know how the girls do. You can put a little heart there if you want. I love math. Oh, wouldn't that be fun and fancy? None of that crap. Don't do that crap. All right. In the numerator, we do not distribute. It won't be obvious on the... Where is that problem? First, I think I might have actually left it out. I'll tell you why in a second. I'll show you why in this problem. So I end up with 2, 8 minus I. Now the denominator, it's 8 times 8, which is 64. Now I could do the middles, but they're going to cancel the same way. This is negative 8i. This is positive 8i. I'm not going to do it. Not going to do it. So now the only thing I have to multiply by is the i's. I times negative I is negative I squared. Now you have to be very, very, very careful here, kids. I squared is negative 1. So put it in parentheses like that, because now what do you see here? You see negative, negative, which makes a... I didn't hear you. No, I still can't hear you. Speak up. Oh, crap, you're not even here. Okay. So in the numerator, I end up with 2, 8 minus I. In the denominator, I have really 64 plus 1, which is 65. Now, here's why you wouldn't want to cancel it. Let's say this turned out to be, let's say when you did this math, by the way, 65 was the right answer, but let's say when you did this math, you ended up with 30 here. Now, the reason you wouldn't want to cancel, I got to keep going. 2 goes into 30. 15 times, and then you'd have to finish it like that. So you just have to look to see if there's any simplifying left to do. That's why you don't want to distribute. For some reason, I might have left that problem out. I'm not sure why. Let's see. So we're going to multiply by the conjugate, which is 1 plus 2i. 1 plus 2i. Don't distribute in the numerator. All over. 1 times 1 is 1 minus, it's always minus because it's always a positive times a negative, 4i squared. Now, I'm going to rewrite this one because this one's a little bit more complicated. So 6, 1 plus 2i all over 1 minus 4 times negative 1. Well, what is 4? Negative 4 times negative 1. Isn't this just turn out to be 1? Negative 4 times negative 1 is plus 4. So my denominator is 5. So my final answer is 6, 1 plus 2i over 5. All right, it's at this point in class, whenever I give you a you try, that you would try these problems on your own. So you probably want to press pause, see how you do with them. I'm going to save and I'll be right back. All right, here we go. We're going to just quickly factor. By the way, don't do this. Oh my God, math is so easy. The answer is negative 9. Oh, negative over negative 9 over 5. That's it. Oh my gosh. If you're in trig doing that, or if you're in algebra 2 doing that, remember, everything that's added and subtracted, put in parentheses so you don't do anything stupid. In the numerator, we're going to factor. Boom, boom, boom. X, X. They have to multiply to 14 and add up to negative 9. Oh, negative 2, negative 7. Bam, 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 bam. X and X. They got to multiply to negative 14, but add up to negative 5. Wait, it's negative 14 this time, so one of them's got to be positive. One of them's got to be negative. Since they have to add up to negative 5, I know that's got to be negative 7 and positive 2. All right, because those add up to negative 5. Then I know the x minus 7's cancel, and here is my answer. Moving on. Nothing to do in the numerator. 4. By the way, pause. You should be trying these on your own. In the denominator, I can take out a 4x. I'm left with 5x minus 3. 4's cancel. This x cancels with one of those. I'm left with x over 5x minus 3 in parentheses, so I don't do anything stupid. All right, pause it, come back. I'm going through these quickly. I'm not here to teach you. Well, I'm going to teach you when I go through it, sort of, but you should pause it, try it on your own, then come back. If you got the right answer, then you don't need to worry about it. You know what I'm saying. Numerator, dots. X plus 6, x minus 6. Denominator, not dots. Ooh, it's a perfect square trinomial. What multiplies to 36 that adds up to 12? Oh, that's 6 and 6. One's plus, one's plus. In this case, they're both plus. The x minus 6's cancel, and I'm left with x minus 6 over x plus 6. Man, math is so much fun. Rationalize the denominators. Write your answer in simplest radical form or in simplest a plus bi form. A plus bi form just means you're going to end up with a real number and an imaginary part. Shouldn't be a problem. All right, let's do this. So we're going to rationalize the denominator. We're going to multiply by radical x over radical x. So I end up with 5 radical x over x. Done. In this one here, we're going to multiply by the conjugate, which is radical 2 plus 4. Radical 2 plus 4. So in the numerator, don't distribute. 5 radical 2 plus 4 all over. Now, again, I only have to do these. Square root of 2 times the square root of 2 is 2. Minus the negative 4 times positive 4 is negative 16. So my answer is 5 square root of 2 plus 4 all over. What is 2 minus 16? Negative 14. I do not like negatives in the denominator. Just hate them there. Put it out front or put it in the numerator. 5 square root of 2 plus 4 all over 14. So we got to multiply by the conjugate here. The conjugate is square root of x minus 6. Square root of x minus 6. So in the numerator, I get 3 square roots of x minus 6 all over square root of x times the square root of x is x. We don't need to do the middles because they will always cancel. Positive 6 times negative 6 is minus 36. Kabam. I didn't even... Oh, I think maybe later. What is the conjugate of this? Remember, the conjugates are the exact same thing, but the only thing that gets changed is the sign in the middle. So don't change two signs. It's only one side. So the conjugate of this is negative radical x minus 4. Only change is that. What is the conjugate of this? The only thing that changes is the middle sign. Xi plus y. What is the conjugate of this? A minus bi. All right, let's see what we got here. I got an I in the denominator. I don't like I's in the denominator, so I need to get rid of it by multiplying by 1. I got to multiply by 1. The problem is this. It has nothing to do with the numerator. The problem is that. So I need to multiply by I over I. So this gives me, now, with i's, I do want you to distribute. So we're going to distribute that I. Let me write it like this for you. I times x plus 3i, all over 5i squared. Now in the numerator, I want you to distribute because it needs to be written in a plus bi form. So in the numerator, we're going to get ix plus 3i squared. Just distribute it. All over negative 5. So let's clean this up a little bit more. This is I times x minus 3 all over negative 5. Now, that's not a plus bi form. A plus bi form means we have a real part and we have an imaginary part. This is the imaginary part. This is the real part. So here's how we're going to write this. We're going to write this as negative 3 over negative 5. Isn't negative 3 over negative 5 just 3/5? So 3/5. And then I'm going to do this one. Well, that's a negative, so minus I x over 5. There's your answer. All right, we're going to get rid of this I. I don't like it. I want to get rid of it. So in the numerator, I'm just going to distribute right away. So I get 3I minus I squared all over 2I squared. So I'm going to do this right here. I'm going to say, oh yeah, you're -1 and you're -1. So in the numerator, I have 3I. Now negative makes a +1 all over -2. And again, this part is your real part. This part is your imaginary part. So we're going to put the real part first. So 1 over -2, that's just -1/2. And then this is also negative, so minus 3I over 2. Again, this is the A and this is the BI part. This is the imaginary part. This is the real part. Now it's just getting crazy. Now we're just getting crazy. Crazy. So we got to multiply by the conjugate, which is 3 plus xi. 3 plus xi. And again, when there's numbers there, I just don't want to distribute. But when I got this, I got to distribute. Now the denominator is the easy part, actually. 3 times 3 is 9. Negative times positive is negative. It's x squared I squared, right? Xi times xi is xi squared, x squared I squared. All right, so the numerator is going to be a little bit more funky. 3 times a is 3a. A times xi is plus axi. And then we got to distribute here. I times 3 is plus 3i. And then plus xi squared. Holy crap. Woo! Let's do the denominator first. This is really -1, so 2 negatives make a positive. So this is really 9 minus x, really 9 plus x squared, because negative make a positive. All right. Over here, this is really -1. So let's put all that stuff first. 3a minus x. 3a minus x plus, I'm going to put this stuff next. axi plus 3i. I'll just leave it like that. Putting that in a plus bi form would be stupid. So I wouldn't ask you to do on that problem. All right, let's talk about this problem. This problem is a little bit less stupid. Not much though. So we're going to multiply by 2 minus I. Well, I never use this stuff in the class. I'm not going to use this stuff. You're going to use it to pass my test. Oh yeah, or your teacher's test, or somebody else's test. But you're going to use it. So suck it up, bro. So in the denominator, we're going to double distribute. So I get 4 minus I squared. I'm going to take care of that right now because this is -1. So negative make positive. So that's just 5. That was easy. All right, let's double distribute this numerator. I get 12 minus 6i plus 8i minus 4i squared. All right, so I remember that this is really -1. So -4 times -1 is really +4. 16 and 4, or 12 and 4 make 16. -6i plus 8i is plus 2i. I. And if I wanted to write it in a plus bi form, it would be 16 over 5 plus 2I over 5. That's an a plus bi form. All right, so let's see what we got here. So just some final things about how you can use your calculator to help you out. If I type this in my calculator, if you were to type this in your calculator, because this was earlier, we had a problem like this earlier. Let me get at my calculator, go find a problem. So if I multiplied parentheses 5 plus radical 3 times 5 minus radical 3, like I did earlier, and I enter, I get 22. And I come back over here, where was that problem? There it is. So up here, when I did this problem, notice I had to multiply these two together. So if you're struggling, sometimes, you can use your calculator. Sometimes. What about example 8? Now, example 8, I got to look back at my notes. So let's type this in our calculator. Let's type in, all right, I'll come back to that. Where are my notes? Where are my things? All right, this thing didn't appear on, somehow this got knocked off. I can't find it. So I know on your notes it says, is it down here? Nope. On your notes it says type in 6 over 1 minus 2I, which was what number 8 was, I believe. Example 8. Let's go back up to example 8. Right. 6 minus 1 over 2I. So let's type that into our calculator. Let's just see what we get. Let's just see what happens. So control division, and it's 6 over 1 minus 2I. 1 minus 2, and then the i's down here. And I hit enter. And 6/5 plus 12 over 5. Oh, I didn't leave this in a plus bi form. Ooh, that's my mistake. Let's do that real quick. If I distribute this 6, I get 6. Let me do it away from my bald head so you can see it. I get 6 plus 12i all over 5. So to write this in a plus bi form, it's 6 over 5 minus 12i over 5. Now, if you'll notice, I'm pretty sure that's what we got right here. We got that right there on our calculator. See right here? Same answer. Yay! But it doesn't always work that easy. Sometimes the calculator helps you out. Sometimes you just have to struggle through, like on these kinds of problems. So let's do a couple. I think I got 3 left problems, and then we're done with this day. So done with day 1 of the middle unit. All right, let's do this. So we're going to multiply by 2 minus the square root of x. 2 minus the square root of x is just the conjugate. So in the denominator, I get 4 minus the square root of x times the square root of x is just x. In the numerator, I got to double distribute all that out. So I get 4 minus 2 square roots of x plus 2 square roots of x. And then what's the square root of x times the square root of x? It's just x, so it's minus x. So my answer here, well, that is my answer, because you can't combine anything. That's it. You're done. Oh, 2 left. So in this one, we're going to have to multiply by the conjugate of the denominator, the square root of x minus x, square root of x minus x, put in parentheses. So in the numerator, if I distribute, I get x. The only thing you don't want to distribute is a plain old number, unless you're dealing with i's. So if you're getting rid of radicals in the denominator and you just have a number, don't distribute the number, but everything else should be distributed. So x minus x square roots of x all over square root of x times the square root of x is x. Positive square root of positive x minus x is minus x squared. Well, we have a little bit of a problem here. In the numerator, don't I have a GCF? How about in the denominator? Do I have a GCF? I do. So in the numerator, can't I take out an x and I'm left with 1 minus the square root of x? Remember, if you take out everything, you still got a 1 left. What can I take out of the denominator? Oh, I can take out an x. Take out an x. Take out an x. I'm left with 1 minus x. Well, wait a second now. Those x's cancel. So my final answer here is 1 minus the square root of x all over 1 minus x. And those are not the same thing, so don't cancel them. All right, one last problem. I have this I in the denominator, so I'm going to multiply by its conjugate. 2i plus x, 2i minus x. All right, in the numerator, I am going to distribute. So I get 6i squared plus 3ix all over 2i times 2i is 4i squared. Oh, that should be a plus. Minus x squared. All right, let's clean this up a little bit. This is -1, and this is -1. So in the numerator, I end up with -6 plus 3ix all over -4 minus x squared. Good enough. Done. Woo! Hit the subscribe button. Hit the like button. Leave me a comment. Don't tell me how ugly I am. I already know. I don't even care. I don't even care. I gotta cut my hair today, though. It's getting kind of long. Bye, kids. Catch you on the flip side.